a little bit about temperature control. So a lot of these things we've actually talked about in other videos. So this is going to be a little bit of a review. But let's begin. Do you guys remember what the difference is between an endotherm and an ectotherm? Or maybe you can think of maybe their more common name, which is warm-blooded and cold-blooded. So our endotherms are going to be our warm-blooded, and our ectotherms will be our cold. There's a tiny cheat for you guys. So an endotherm is able to somewhat regulate their own body temperature, and an ectotherm would not be able to do that. So when we think about ectotherms, we think about like reptiles laying on a hot rock in order to warm their bodies, or when alligators are going to stay on the shore for most of the afternoon. They're not even in the water that much to warm up their bodies, okay? And good. A few of their adaptations that they're using include fur or blood flow or capillary action, some specific behaviors which we'll give some examples of, and using the environment. So let's go from the bottom first. Using the environment. Sometimes animals will bury themselves in order to control their temperature. And depending on the season, that could help them decrease or increase their temperature. When we're thinking about hibernation, and animals that are doing true hibernation, they're going to basically bury themselves underground with everything that they need in order to shelter themselves from the snow. At the same time, animals might cover themselves in mud to protect themselves from the sun, or roll around in mud in order to get water on their skin and protect them from dryness or also just dehydration. So animals are using the environment all the time. Some things are a little bit more logical, right? Sometimes if an animal is really hot, they will go for a swim. They will drink out of a cool river. These are things that they're doing to regulate their body temperature. And one of the largest tools, the largest tool to regulating body temperature using the environment is water. Are we avoiding it, or do we need it? Most of the time when we're avoiding it, it's because we're trying to warm ourselves up. And when we need it, it's because it's very hot and we're trying to cool ourselves off. So water, you can think about that. Some behaviors that help with temperature control. Do these animals shed? Do these animals take off layers of their skin? Do they, by shedding, I mean, is fur coming off, is skin coming off? Are we going to huddle together for warmth like penguins and work together and use these other behaviors? Or are we more on our own and we're going to travel to warmer places? These are some of the behaviors. A lot of animals, though, love to work in teams. And so they will be together in order to stay warm. In the environment, birds, for example, are going to huddle together. You can see them all fluffed up. They might puff up their feathers. This is a behavior that they do, and the reason that they do it is because they're trying to increase warm air underneath their feathers and increase their body temperature. So that's what they're doing when they're fluffing up their feathers. And we kind of actually have that same adaptation. That's where goosebumps come from, or when the hair stands up on your arm. These are old adaptations that we don't really use anymore in the environment that we live in. But when your hair is standing up on your arm, it's because you're trying to maintain some of that warm air and trap it under those hairs and keep it close to your skin to stay warm. Same thing with shivering. You're trying to warm yourself up. So these are some of those behaviors. Endotherms will also increase their blood flow and capillary action to bring warm oxygen and blood up to the surface of your skin in order to warm yourself up. And lastly, and probably the most fun, is fur. So we have our musk ox fur here really quickly. This is a great example of using adaptations to stay warm. Sure, animals have fur, but animals, for example, if you have a dog, you notice their hair, it comes out a ton in the summer. They're shedding, they're decreasing some of those coats, right? Our musk ox, I'll try to go a little bit closer. You can see underneath here, there's kind of a woolly section underneath this musk ox. You can see it on the edges. So what happens is normally an animal would shed their top coat, but what the musk ox does is they actually shed this bottom coat, this woolly layer, when it is getting warm, and they keep this top part because it is waterproof. And so again, that goes back to this, how are we using the environment? Do we want water, or are we avoiding it? In this case, in the winter, this is great because it's going to keep snow off, like a waterproof jacket, and then they have this wool underneath. And when it gets too hot, this wool will go away and they will keep on their waterproof jacket. So these are just a few ways that animals regulate body temperature and combat the elements.
All right, guys, so for our activity this week, I want you guys to try and test some different forms of temperature control. Now we're gonna do it like a formal experiment, like scientists do. And honestly, this is actually how scientists do their different kinds of experiments, is that they follow these steps and they record them and then they send them off and they get published, okay? So we're gonna be following them exactly like scientists do, and we are going to be putting them in our field journal because we're going to write all of this down. So first things first, we're gonna ask a question. The question being, how do animals stay warm? We're gonna form a hypothesis, and I'm going to give you 3 different ways that you can test this. If you can come up with any others that you think would be interesting, go ahead and test those too. But I'm gonna give you 3 different ways of testing, and I want you to hypothesize or guess which one will be the most effective. So we talked about earlier ways that animals temperature control for cold. One of the ways is hair. And we talked about in a previous episode that one of the ways is layer of fat. We talked about that in our hibernation video. So we're gonna do a test with nothing on our hands to protect them, some fur or something like it to protect our hands, and something with fat on it, okay? So here is the experiment. These are the materials that you'll need. You're gonna need some ice water in a container that you can put your hand into. All right, so what you're gonna do is you're going to put your hand into a Ziploc baggie with nothing in it, and then put it in the ice water and see how long you can keep your hand in the ice water before it starts to hurt or before you decide that's too cold and you pull it out, okay? You're gonna do that again with something like a sock or a mitten over your hand, or even just a kitchen towel wrapped around your hand. Put it in the Ziploc baggie, put that into the water. See if you can see how long you would last with that amount. That replicates kind of like fur. Now the final one is going to be more like a fat layer or like blubber. You're going to put some fat into a baggie. You can ask your parents for help with this one. The best one I would recommend is probably Crisco, but you can also use something like butter or margarine if your parents are okay with you using that. And you put it inside the bag, you put your hand inside the butter, margarine, lard, or Crisco, and then you put it in the water and see how long you can keep your hand in there. Make sure to record everything about it. Afterward, record how it felt, record how much, like the amount of time. That's recording data, okay? And then finally, you're gonna look at it, you're going to analyze it and say, all right, I tested it in these ways, and I found that the one with the fat was the warmest, or the one with the towel was the warmest, okay? So you're gonna analyze what you said about it, okay? And you're gonna do all of this for a nice cold temperature, and see if maybe you can come up with one for a warm temperature experiment as well. One thing that you could try is something with misting water on your skin to see how your temperature cools, or without water, how much it raises. So see if you can come up with an experiment similar to this one, following these steps: question, hypothesis, materials, experiment, recording data, and analyzing. See if you can come up with one for warm temperatures as well. And good luck on your scientific endeavors, and we'll see you next week, guys.